Hey everybody, Mr. Qualls. This is my second attempt at this video. The first one didn't go, well, it went really well, but the computer crashed as I was uploading it, so kind of lost it, so we'll try again. What we're going to look at here is calculating circumference and the distance, which is the distance around circles, or the length around a circle. Before we do that, we need to make sure that we're all dealing with the same common vocabulary. So the word circumference is our first. Circumference is the distance or the length around a circle. The radius is the distance from the center of the circle out to the edge of the circle. Diameter is the distance across the circle. It has to go through the center. Okay. If you see a line that looks like this, that is not a diameter. It's called a chord, and it's used for other things later in geometry. But the diameter has to go through the center, and what that does is it guarantees that we will have the longest line that we can inside the circle. The diameter also is twice the radius. So that's going to be something that we talk about here in just a minute. So the diameter is twice the radius, and the radius is half of the diameter. And of course, the center is the very middle point of the circle. It's not actually part of the circle itself. I always find that it's fascinating that a circle is defined by a part or something that is not actually a part of the circle. The center isn't attached to the outside at all, but that's a discussion for later. So when we're talking about circumference, what we have is the idea that the length around the circle is related to how far it is from the center to the outer part of the circle. So this is really what pi is. And if we look at this idea of radius here, I'm just going to call this radius 1. And then if I was to take this radius and put it around the outside of the circle and lay that length on the outside of the circle, it would go 1, and then I would get it 2, 3, and then right over here for the halfway around the circle, I would get 1, 2, 3 of those lengths, and then 14% of another one. So that would be 3.14 times. If I did that with a diameter, and I took this diameter and I wrapped it around the circle as a measuring device, it would go around 1, 2, 3, and then I would get 0.14 again over on the other side. So the diameter goes around the circle 3.14 times. The radius goes around halfway 3.14 times. That is what pi is. It's a relationship of the ratio between the length of the radius of the circle and how far it is around half of the circle. Now later on, when people get more sophisticated with their use of pi and circles, what happens is if you make this 1, it's 3.14 around this way, or 1 pi in distance. If we make this 2, this is 2 pi. If it's 3, it's 3 times pi around. If it's 10, then it's 10 pi around, halfway around the circle. And then if it was 10 pi around half of the circle, it would be 20 pi around, or 2 pi times the radius around the circle. So that's how these are developed as formulas. Now, the second thing we need to talk about pi itself is that pi is it's a special number. Pi is a special number, and if I want to refer to pi as how far this goes around this circle, and I want to mention pi as a perfect number with all of these decimal places behind it, I either write this symbol or I say pi. I can't write all of those numbers out because pi is an irrational number. It goes on forever. It's non-terminating decimal, and it never repeats. So it's an irrational number, and because it's an irrational number, I can't write it all down. Another thing that we use for pi is 22 over 7. Now 22 over 7 is an estimation of pi. And you can see that when it goes out 3.1428, it's not the same. This is 1.5 and this is 2.8. So they're not the same. Well, if we look at pi and we thought that this was meters, the 3 was meters, and then the 14 were centimeters, so 3.14 meters or 3 meters and 14 centimeters, this 1 right here is actually a millimeter. And this would be 5/10ths of a millimeter. And this would be 9/100ths of a millimeter and 2/1000ths of a millimeter. We don't measure anything down to that. I mean, some people do, but those are more sophisticated operations when they need things to be really, really specific measurements. Same thing here with 22/7. This is the meters, these are the centimeters, and then we've got 2 millimeters, 8/10ths of a millimeter. And that means that these numbers right here, the 1 and the 2 are millimeters. So even these things right here, even out to the 1,000th of a meter, they're 1 millimeter apart. So we rarely measure things down that closely. So what I'm going to do is I'm going to take this, and you know what? I don't need that. So I'm going to round it to 0.14, and then I'm going to round this one to the hundredths as well. And look, they're both the same number. So now they're both the same approximation. So I can use either one of them for the problems that are like the ones that we are going to deal with. So we don't need to use an ultra sophisticated value for pi because we're just doing simple operations right here. We're just starting to use pi. We're kind of standing up and walking with it. We're not going to run. All right. So what we're going to do is we're going to use these two ideas because the radius times 2 times pi is the circumference over here. And here, if we're given the diameter, it's pi times the diameter around that. So if I'm given the radius, I'm going to use that formula. And if I'm given the diameter, I'm going to use this formula because it's just simpler that way. So my first problem, I'm going to define this radius as 9, and I'm going to define this diameter as 6. And I'm going to calculate both of these things. Now, I have my radius of 9, so what I'm going to do is I'm going to start with that formula right there. My C equals 2 pi times r. Now, I always start my problems by writing my formula first, and then I'm going to substitute into the formula, so C equals 2, and then I know what pi is. I'm going to use this approximation of pi, 3.14, and then I'm going to use r, which is 9, and everything I'm putting in parentheses, or everything I'm substituting, I'm putting in parentheses because I want to keep the numbers separate still, but I want to know that there's still multiplication. Now, this is all multiplication, and the associative properties of multiplication and the commutative properties of multiplication, see, I can do it in whatever order I want to, and I can move them around. So I'm going to use the commutative property of multiplication, and I'm going to move that 9 up front with the 2 so that I can put the numbers that are whole together. They're integers, I might as well put the integers together and use my decimal, okay? So from there, what I'm going to do is I'm going to simplify this. Almost all formula work is just about simplifying so that we can get down to one idea. And what we're trying to do is we have 3 ideas here. If we had 2, that would be a little simpler, and then the 2 can become a 1 idea. So I'm going to take the 2 and the 9, and I'm going to make this 18, and that is going to be multiplied by 3.14. And then 3.14 times 18 is 56.52. Now, let's see if that answer makes sense. Now, I was guessing that I had this number is close to 3, and this number is close to 20, and 20 times 3 would be 60. So I rounded up for this one to be 20, so it's going to be a little less than 60, and here we go. So we're probably on the right track. Now what I need is my measurements, because if this is a circle with a diameter or with a radius of 9, it's actually 9 centimeters. So I'm going to mark this as well because it is a distance, and distance or a length has a measurement, a one-dimensional measurement. It's going to be centimeters on this one. I'm also going to put my answer in a rectangle so that when someone looks at it, they can see I've identified my answer and it's marked in a rectangle. So here's what I did. I needed to find the circumference. I looked at my problem. I have a radius. This is for radius and this one's for diameter. So I'm going to use my radius formula. I wrote my formula down. I substituted the things that I know about the numbers into the formula. I moved the 9 up with the 2 to simplify the problem. 2 times 9 is 18 because 3 numbers, if I put these 2 numbers together, it becomes 1 number. Now these 2 numbers together become that, and I'm finished after I put my label on my problem. Okay? So on this other problem down here, I have a diameter of 6. So I have a diameter this time. I'm going to use my diameter formula, because if I cut this in half and make it a radius and put a 3 in for this, 3 times 2 is 6, and now we're back to 6 anyway, we might as well just cut to the chase and use the diameter formula. That's what it's for. So here's what happens with this formula. C equals pi times d, and I'm going to substitute into this formula what I know, 3.14, and then my diameter is 6. Okay. Now I don't have to move anything around. There's only 2 numbers, and I want those 2 numbers to be the same, or I want them to be 1 number. So I'm done simplifying, or I need to simplify. So let's look at it before we calculate it. 3 times 6 is going to be 18, and then this right here is going to make it a little more than 18. So when I get my answer, I already know kind of where we're going, and 3.14 times 6 is 18.84. So I was expecting to get an answer a little more than 18, and I did. Probably where I want to be. So again, let's look over here. What are my measurements? Well, it was 6 inches. So I'm going to come over here, 6 inches, or excuse me, 6 inches through here becomes 18.84 inches. We're done. All right. Again, I identified, I have my diameter. I'm going to use my diameter formula. I substituted, got my answer, put my label, marked it in a rectangle so that someone else looking at this knows that is my answer. That is my final piece of this. Okay. So every once in a while, we get in a situation where we have things like this. This is how it usually goes. We have numbers and decimals, or whole numbers or integers and decimals and those kinds of things, and they work very, very well together. Sometimes, however, we get something like a fraction in here. And when we get fractions, things can get very complicated very quickly. In fact, I would rather not use fractions if I'm using decimals, because decimals and fractions don't really go together. You end up with decimals on the top, and then you have this thing called a complex fraction, and it usually is a mess. So if we get a situation, something like this, and this is a very special situation, but you can use this in, and it makes things simpler. If we had a radius over here of, let's say, 7/2, okay, which is really 3.5. So if I had 7.2 as my radius, I could use this and put my 2, and then my radius is going to be 7/2. And instead of using 3.14 for pi, what I'm going to do is use my 22/7, because there's a fraction over there. 22/7, fractions like fractions. So I'm going to make the 2 a fraction as well. Every whole number is really a fraction if you just put a 1 under it. So now I've got 22, or 2/1, 22/7, and 7/2 all multiplied by each other. Well, everything on the top is going to be together anyway, so I can write them in whatever order I want. So I'm going to do 22 times 22 times 7. Everything on the bottom is also going to be multiplied, so I can put anything on that in order, in whatever order I want there as well. So I'm going to move the 2 into the front, and I'm going to put the 1 under here, and then I'm going to put the 7 over here, just to show you what's going on. Well, 2/2 is 1. 7/7 is also 1. 1 times 1 is 1 times 22 is 22. This is why we simplify things this way, is because if there's a 1 in the problem and it's being multiplied, anything times 1 just keeps its own identity. This is the multiplicative identity property in practice, because if we can identify 1s in a multiplication problem, we can get them out of there. And C now equals 22. And well, if it was centimeters, it's still centimeters. Mark my box there, okay? Now, am I right? Well, this would have been about 3.5 times 2 is 7, and then 7 times something close to 3 is around 21, and that's pretty close to 21. I think we did a pretty good job here, okay? So, thanks for watching the video. Everything you need to do the 9 problems that are on this worksheet is right here, okay? Tomorrow we will meet for our meeting on Zoom, and I'll answer any questions off the homework. If you need multiple questions worked out, whatever we need, we'll do it, okay? All right, so I'm out.